All right, and welcome to this video on complex numbers. Okay, so today in class we talked about complex numbers, but there's a bit of a mistake, and so I wanted to correct that because you guys are going to need that to do your homework. So just to make sure you watch this video before you actually begin your homework. Okay, so first off, we started talking about Euler, and we started talking about what he did with imaginary numbers. Okay, so we established in the beginning that the square root of -1 is actually equal to I. Okay, so I has been established as the square root of -1 here. Okay, so we also talked about that is basically the definition of an imaginary unit. I is equal to the square root of -1. Then we talked about what happens if we actually put another value there. So let's say I have the square root of -a. Well, I can separate that into the square root of -1 times a, which is equal to the square root of -1 times the square root of a. And then I can separate those because I know that the square root of -1 is going to become I. And so that would give me I times the square root of a. Okay, we also practice with some additional values such as, okay, what if it's the square root of -2? It works the same way. The square root of -1 times the square root of 2. Well, the square root of 2 will remain the square root of 2, and the square root of 1 will become I, giving me I times the square root of 2. What happens if it's negative perfect square? So we have the square root of -1 times the square root of 25. Well, the square root of 25 will give us 5, and so the square root of -1 will actually give us I. And so that is 5 times I is my final answer. Okay, then what happens when we have a number such as the square root of -8? Well, basically that will be the square root of -1 times the square root of 8, which comes out to be the square root of 4 times the square root of 2, and the square root of 4 is 2 times the square root of 2. And so I end up with, this becomes I, and so we have 2I times the square root of 2. And you can also write that as 2 times the square root of 2 times I, but just make sure that the I is not under your brackets. Okay, so either of these two are acceptable answers. Okay, so where the mistake was when we got to I squared. So we have I, the square root of -1 squared is equal to, well, I squared, because we know that the square root of -1 is equal to I, and therefore the square root of -1 times the square root of -1 would be equal to I squared. But what does that mean? Let's explore that a little bit more. Well, whenever you take the square of a square root, it ends up being what is under the radical. So in this case, the square root of -1 squared should actually be -1. So I squared would actually be -1. So I squared is -1, not 1. All right, so we went on to basically multiply those out. And so we have the square root of -2 squared, and so what that would be the square root of -2 times the square root of -2. Well, let's explore that further. Well, that would be the square root of -1 times the square root of 2, and this would also be the square root of -1 times the square root of 2. Well, what happens to each of these square roots of -1s? Well, this becomes the square root of -1, and this becomes the square root of -1, and so that actually becomes I squared. And then I also have the square root of 2 times the square root of 2, which becomes the square root of 2 squared, and the square root of 2 squared is 2. So basically my final answer, because I squared is -1, and the square root of 2 squared is actually 2, my final answer is actually -2. Okay, so if you wanted to continue to prove that, you could, but basically we can look at any of these and say, okay, well, if I square the square root of -25, that would give me -25. If I square root the square of -5, that would give me -5. And if I square the square root of -8, that would give me -8. And the same thing with -9 if that were squared. Okay, so then we went on to develop the meaning of I cubed. Well, if I is -1, then I cubed has to be -I. Well, let's look at how. Okay, so I'm going to come over here and do some work off to the side. If I have I times I times I, Well, most of you understand that that would be I cubed, but let's dig a little deeper. Well, basically, we know that that's the square root of negative 1 times the square root of negative 1 times the square root of negative 1. Right? So all these are multiplied together. And now let's separate that. So the square root of negative 1 times 1 times the square root of negative 1 times 1 times the square root of negative 1 times 1. Well, let's see it again. Well, this becomes the square root of negative 1 times the square root of 1 times the square root of negative 1 times the square root of 1 times the square root of negative 1 times the square root of 1. Well, let's put all of those negative square roots of 1's together. So we have 1 here, here, and here, and I'm going to multiply those all together. So negative square root of 1 times, the square root of negative 1 times the square root of negative 1 times the square root of negative 1. And then I'm going to multiply all the square roots of 1's together. So times the square root of 1 times the square root of 1 times the square root of 1. Well, I know that each of these will become an I, right? So I will end up with an I. And over here, I will end up with an I. Well, I times I becomes I squared. And what do we know about I squared? Well, let's go back up here and look. We now know that I squared is negative 1. And so this I squared will actually be replaced with negative 1. And what do I have left over here? Well, I know that the square root of negative 1 is I, so it's going to be times I. And I know that the square root of 1 is 1. And so for each of these, I would just be basically multiplying by 1. And so my final answer would be negative I. Now, you don't need to remember that. The only thing that you need to know is that I cubed will give me negative I. But if you forget, then of course you have to derive all of this. Okay, now the last one that we come to is I to the fourth. So I to the fourth, basically, in order to get that, I could break down I squared times I squared. And wouldn't that give me I to the fourth? Yeah, of course. So since we have established that I squared is what? You should have it by now. I squared is actually negative 1. Then I squared times I squared would give me negative 1 times negative 1, which would give me, of course, if you guess positive 1, that's correct. So that would give me positive 1. So I to the fourth is actually positive 1. So if I had to make a list, I would start out with I being the square root of negative 1, I squared being negative 1, I to the third being negative I, and I to the fourth being positive 1. If I continue this pattern to go I to the fifth, I to the sixth, and so on, basically the same pattern will repeat every 4 exponents, right? So I to the fifth would become the square root of negative 1 again, and then I to the sixth will become negative 1, I to the seventh would become negative I, and I to the eighth would become 1 again. And so that pattern just continues to repeat itself. Okay, so then we looked at the difference between complex and imaginary numbers, and we talked about complex numbers being all numbers, because all numbers have a complex component and an imaginary component and a real component. So this would be the imaginary component, and this would be the real component, and both of those components make up the complex number. Now, what happens if one of those components is 0? Well, if the real component is 0, right, then what we get as a result is just a pure imaginary number. So basically, there's no real number there, just the imaginary component. And so we call those imaginary numbers. Now, what happens if the real component is there and the imaginary component is not? Well, that's what happens with most numbers, right? Your imaginary component is missing. And so what we end up with is basically a real number. Makes sense? So together, they are a complex number. If you just have the imaginary part, it's an imaginary number. If you also have the real part, then it's a real number and not an imaginary number. Okay, but they're all complex numbers. Then we looked at, okay, how do you add these? Okay, so in this case, basically, we add them very similar to binomials. So if I had to add x plus 2, nope, not times, that's not what I wanted to do. If I wanted to add x plus 2 plus x minus 1. Basically, I would say, okay, x plus 2, and since there's no negative sign here, that would just be like multiplying by 1 outside the brackets, and so that would make everything the same inside. So plus x minus 1. And so I would combine only like terms, which are x's. So that would be 2x. 2 minus 1 would be plus 1. Well, it works the same way with imaginary numbers. I can only combine like numbers. So remember we went over the number properties in the beginning? I can only combine real numbers with real numbers and imaginary numbers with imaginary numbers. And of course, they have to have the same exponent. So if I add these, it's going to be 4 minus 3i. And because it's a plus sign, everything in the second parenthesis stays the same. So that's going to be minus 4 and then plus 3i. Okay, well, let's simplify that. Well, 4 minus 4, that's going to cancel to 0. And negative 3i plus 3i, well, guess what? That's going to cancel to 0 as well. And so all I'm left with is just a real 0. Let's try it with another type of number. So 5 minus 3i, and then that would be minus negative 2i plus 4i. Well, the minus is going to make me multiply everything inside the parentheses by a negative 1. And so that's 5 minus 3i. And so all the signs will change to become opposite of what they are. And so that would be plus 2. And then, so because it's negative 1 times negative 2, and then negative 1 times positive 4i would become minus 4i. And so then I would combine the like terms. I can see that my like terms are 5 and positive 2. So that would become 7. And then my other set of like terms are the imaginaries. So to get the imaginary component, I would subtract negative 3i minus 4, which would give me minus 7i. Okay, so I hope this part has helped. And you can take a minute and practice number 3 and number 4. Just pause the video and work them out. Okay, so if you work those out, then you can see that you should have gotten, well, 7 minus 3 is 4, and negative 2i plus I would give me minus 1i. And in the other case, you should have gotten 4 plus 4 is 8, and negative 3 minus 3 would give me negative 6. So that would be 8 minus 6i. Okay, so now let's go on to see what happens when we actually multiply these. All right, so let's start with the first set. If I'm going to multiply, then I'm going to multiply it just like I would two binomials. So x plus 2 times x plus 3. Basically, I would multiply x times x and x times 3. So that would give me x squared plus 3x. And then for the second term, I would multiply plus 2x, then plus 6. So that would give me x squared plus 5x plus 6. Well, I'm going to do the same thing over here. And so I'm going to multiply the first term, so that would be 16, and then the outside terms, so plus 12i, and then the inside terms, so that would be plus 12i, and then the last terms, and so that would be 9, so plus 9i squared. Well, again, remember that we can only combine like terms, so we can combine the i's, so that would be 16 plus 24i, and then of course plus 9, but now we've learned that I squared is negative 1, so that will affect the answer that we previously got. So that would be 16, and that would be minus 9, and that would be plus 24i. So that's going to change. 16 minus 9 will actually give me 7 plus 24i. Okay? So you can look back through this one or work it out on your own and then try the next one. Pause the video and try it. Okay, so if you tried this one, then you should have gotten negative 10, right? And then plus 20i, and then plus 6i, and then minus 12i squared. Okay, so we can combine the like terms, so that'll be negative 10, and then plus, well, 20i plus 6i will give me 26i, and then minus 12, and so in order to combine the negative 10 and the 12, we have to make them like terms by replacing I squared with negative 1. So in that case, we're going to have negative 10 minus, actually that'll be plus 12, and then plus 26i. Well, negative 10 plus 12 will become 2 plus 26i. Okay, so now we'll move on to the complex conjugates and see how having I squared as negative will affect our answer. Okay, so in this example, we're actually going to multiply two opposites. So we can see that a plus bi times a minus bi will give us what we call complex conjugates. So that's where we end up with a pair of opposite roots. So our complex roots will be opposite, right? So basically, if I have a plus bi times a minus bi, then I would treat it as if I had x plus 2, right, times x minus 2. Well, what's going to happen there? Well, when I multiply x, I'll get x squared. And then when I multiply x times negative 2, I'll get minus 2x. 2 times x, that'll be plus 2x. And then my last terms, I'll get minus 4. So I end up with x squared minus 4 because the two middle terms cancel out. Well, the same thing happens with complex conjugates. So I end up with a squared and then minus abi and then plus abi and then minus, this becomes b squared I squared, right? And so minus b actually ends up being, sorry, not minus b squared, but negative I squared ends up being negative 1, right? So that's going to be replaced. And negative abi and positive abi will actually cancel each other out. So I end up with a squared plus b squared. Why? Because negative b squared times negative 1 actually gives me plus b squared. So it's actually very opposite of a difference of squares, because we actually are using imaginary numbers, and so we're adding our last term instead of subtracting it. Okay, so let's see how this plays out with complex conjugates. Okay, so if I have 3 times 3, that would be 9. And if I have 3 times 2i, that would be plus 6i. And then if I have negative 2i times 3, that would be minus 6i. And then the last terms, that would be minus 4i squared. Well, positive 6i and negative 6i will cancel, so that will be 9 minus 4 times negative 1. Well, how will that affect my answer? Well, 9 plus 4 will actually be 13. So when you multiply complex conjugates, you actually end up with a real number answer, right? So this is a real number answer, okay? Because your imaginary terms cancel out. And then your I squared, of course, makes your value real. Okay, so let's try it again. So these are actually complex conjugates, even though they look otherwise, right? So this will be negative 16, and this one will be negative 12i. And then the next term will be positive 12i. And then the last terms will be positive 9i squared. Well, negative 12i and positive 12i will cancel, and so we'll have negative 16 plus 9 times negative 1. Well, that will be negative 16 minus 9, which will give me what? Well, if you said 25, you are correct. So that would be negative 25. And so that would be my final answer. Okay, so basically complex conjugates and multiplying complex numbers will be affected by your I term. So just remember, if you didn't quite understand how I is derived, you just need to basically remember these. You need to know that I is equal to the square root of negative 1, I squared is equal to negative 1, I cubed is equal to negative I, and I to the fourth is equal to 1. Okay, I and I squared are the ones that you will use the most, so these two. And anything else is just a bit of extra information, but it doesn't hurt to know it. All right, I hope this has helped, and I will see you in the next video.